All right, let's take a look at this tree illustrating blood types in figure 1.2 in order to answer the quiz yourself question number 1, where they want us to illustrate which of these branches would be our blood type and which would be Brian's. In order to see that, we have to go up and see that our blood type is AB negative and Brian's is type O. So AB negative is our blood type. So we have the A antigen, AB negative. We have the B antigen, but we're negative for the RH antigen. So the branch that represents our blood type would be this second branch here. That's the AB negative branch. All right, and then Brian had, let me go look back at Brian's. Brian had O positive. So Brian has no A antigens, no, oh, that's not a no. No B antigens, but positive for the RH antigen because Brian was O positive. So Brian's corresponding branch is this branch here. That would be the O positive. All right, in Quiz Yourself question number 2, we're asked to describe the students who are represented by the region R3 and also then the region R4. So looking at our figure 1.3, Z represents students taking Zumba and P represents students taking Pilates. So in the region R3, this group would be students taking Zumba and Pilates. And in region R4, that's just this outside space here in the P. So R4 is students who took or are taking Pilates, but not taking Zumba. This is an example of a Venn diagram. We'll see these more in chapter 2. All right, and Quiz Yourself question number 3. We're asked to complete the table. So let's look at the whole problem probably. So we're systematically listing. Nico is considering which optional feature to include with his new smartphone. He's narrowed it down to 3 choices: quick charging battery, multiple windows, and high resolution camera lens. Depending on price, he will decide how many of these options he can afford and how many ways can he make this decision. In Nico's decision, we see that there are 4 cases. Choose none or one or two or all 3 of the options. So we have to make a list of all potential choices, all possible outcomes. So one is none, right? Then we have the options of choosing one. So we have chosen the battery. In row 2, we've chosen the windows in row 3. So we'll choose the camera in row 4. And then we move on to the ability to choose 2 items, which means we're rejecting one. So we don't get the camera in the 5th row. We don't get the windows in the 6th row. So we don't get the battery here in the 7th row. And then the very last row is all 3 options. All right, and quiz yourself question number 4. We're going to list the numbers in the 6th and the 7th rows of the Pascal's triangle. So looking at Pascal's triangle in figure 1.4, you can see how to build it. If you take the 2 numbers above and sum, that's your value. So for example, let's start at the 1, 4, 6, 4, 1 row, row 4. If we add the 1 and 4, we get a 5, and we write that below the 1 and 4 space. If we add the 4 and 6, we write the total below. There are other observations. We always start with a 1. So we have a 1 beginning the row. So let me get my pen out. And we're writing not right beneath numbers, but in a space between numbers. So we're going to add the 1 and 5 to get a 6. We'll write it below, but in the space between as well, below and between. Now add the 5 and the 10 to get 15. Add the 10 plus 10 to get a 20. The 10 plus 5 is a 15. The 5 plus 1 is a 6. And then you see again that we always end the row with a 1. The only one that doesn't begin and end with a 1 is the very first row because it only has 1 number. So that's our row 6. We could write row 7 here as well. Row 7 will begin with a 1. Then we'll add the 1, 6 for a sum of 7. The 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. And 6 plus 1 is 7, and we always end the row with 1. You might notice there's some symmetry going on, right? So the first half of the list is the second half of the list in reverse. And in part B, they're asking us for the sum of the numbers in the 12th row of Pascal's triangle. We have that this, if we continue on the pattern of this table, then we see in the 10th row, we'll have 2 to the 10 for our sum, or 2 times 512. And then in the 11th row, we'll have 2 to the power 11. And in the 12th row, we'll have 2 to the power 12. And we can double 512 to get 1024. If we double that again, we get 2048. And if we double that again, we get 4096. So the sum of the 12th row will be 4096. In Quiz Yourself question 5, we're asked to determine the number of ways email can be sent between the various branches. Notice that email from A to B, written AB, is not the same as email from B to A, written BA. And if we look at the chart and the table, we can see that they've already worked out for us that in just considering the AB itself and not the direction BA, then you can see in table 1.4 that when we get up to 12 branches, there'll be 66 different links. So a link from A to B is just one link. But when we have branches A, B, and C, now you have a link from A to B, a link from A to C, and a link from B to C, looking at table 1.3. So since they've already deduced that at 12 branches we'll have 66 links, considering now the links are one directional, A to B is different from B to A, then we just double the amount of links that we have. So the answer to Quiz Yourself 5 will be this 66 going from one direction, AB, AC, BC, like the chart above illustrates. We'll need another 66 links to go from BA, CA, CB, etc. 66 plus 66. 132. In Quiz Yourself 6, the Field Museum in Chicago, which houses Sue, the largest preserved T-Rex, has acquired 3 more mechanical dinosaurs for a new exhibit. The combined weight of 3 new dinosaurs is 50 tons. If the weight of the Apatosaurus is 7 times the weight of the duckbill and the Diplodocus is 14 tons more than the duckbill. What are the weights of each dinosaur? And we're supposed to be using a guess and check method here. So if we guess, check, and guess again is the goal. So we have the Apatosaurus, we have the duckbill, and we have the Diplodocus. Okay, so if, for example, the duckbill weighs 1 ton, the Apatosaurus is 7 times the weight, so then we have 7 tons. And the Diplodocus is 14 tons more. So that's 14 plus 1, giving us 15. Now, if we look at the total weight, right, we have 15 plus 7 plus 1 for 23. 23 is close, right? It's not quite half. We could double this if the duckbill is 2. 2 times 7 is 14. And 14 plus 2, right? 14 plus 2 is 16. This it sums to, now we have 32 as a sum. We could skip ahead, possibly. Let's see, 5 times 7 is 35, so let's try that. 5 times 7 is 35. And then we'll do 5 plus 14 for 19. That gets us to 59. That's a little too high. So we're guessing again, right? This time I guessed too high, we guessed too high. So we'll try now making I need a little space here, so I'm gonna, well, actually, I'll leave that one. But we'll take out this middle one, just because I need the space. And we'll back it up to like the duck being 4. 4 times 7 is 28. And 14 plus 4 is 18. That now gets us to 30, 40, 50. Bam. So our weights are 4 for the duckbill, 28 for the Apatosaurus, and 18 for the Diplodocus. And that is tons. In question 7, we're asked to assume that the math and sociology are taught in buildings on opposite sides of the campus, and the distance is such that Anthony cannot take them back to back. Use figure 1.5 to determine what schedules are now satisfactory. So they've given us a tree diagram showing all the possible ways to construct Anthony's schedule. But as we can see here, the math and the sociology, so math labeled S, soc labeled S, cannot be taken back to back. That is going to eliminate the first row, 10 to 11. It's also going to eliminate the second row, that 11 to 10. Already that third row is not a possible schedule. The fourth row is fine, right? Because we have 11 o'clock. Oh, I was looking at the A group, not the S group, but I think some of them are valid anyway. Let me start this one over. Okay, our 9 and our 10 can't be next to each other there. So row 1 is out, but not for the reasons I stated earlier, right? So row 1 is out. 9 and 11 are fine, right? That's okay. That's a good schedule there. Now looking at math at 11, on that third row again, that's not a possibility anyway because of the art history class. And now we're looking at math at 11, going to social at 12. That's not going to work. Math at 11, social at 10 is also not going to work. So actually nothing in that math at 11 group works. And if we try to take math at 12, the social at 11 is fine, but the social at 10 is fine, but the social at 11 is not fine because we don't want back-to-back hours. So we only got 2 schedules that Anthony can take actually in this fashion. We got math at 9, art at 10, social at 11, English at 12, or we've got English at 9, social at 10, art at 11, and math at 12. Those are the only available schedules. In Quiz Yourself number 8, we're just asked to find another example that shows that the quantity x plus y squared equals x squared plus 2xy plus y squared. So we can take any 2 numbers that we want. They use 3 and 4. Let's use 1 and 2. So we're going to say that 1 plus 2 squared is 3 squared, which is 9. That's the left-hand side of the equation. And now x squared, that'll be 1 squared, plus 2 times 1 times 2, plus y squared, which is 2 squared. So now I'm looking at the right-hand side of the equation. This is 1 squared is 1, plus 2 times 1 times 2 is 4, plus 2 squared is 4, and 1 plus 4 is 5, plus 4 is 9, and you can see that we got a 9 on the left-hand side and 9 on the right-hand side. So we found another example that shows this equal sign is always true. In Quiz Yourself 9, we're asked to find a counterexample to the following statement. The quantity A plus B divided by the quantity A plus C equals the quantity B divided by C. Let's let A equal 1 and B equal 2, and just what they use. Oh, they didn't. This is one for us. C equals 3. And we're going to show this is not a true statement. So 1 plus 2 quantity divided by the quantity 1 plus 3, and this will equal 3 over 4. So given this example, the left-hand side is 3/4, but just B over C is 2 over 3. 3/4 is not equal to 2 over 3. This is not always true, and we show that using a counterexample. It's sometimes true, but it is not always true. In quiz Law 10, we're asked to consider the equation the square root of the quantity x plus y as to whether or not that equals the square root of x plus the square root of y. Part A reads, on the left side of the equation, we are performing two operations. What are these operations and what is their order? On the left-hand side of the equation, we are first summing the x plus y, and then we are square rooting that quantity. What is the order of operations performed on the right side of the equation? The right side of the equation, we will take the square root of x, the square root of y, and then we will sum them. So you can see, just like in the example, that there's a difference between adding and then taking the square root versus taking the square root and then adding.